All right, let's get right into it. Today, we're not just talking about AI security, we're building your essential toolkit. The threats facing AI are new, they're complex, but the solutions are absolutely within reach. We're going to walk through the exact resources you need to build a really powerful defense, starting right now.
So, this is really the central question, isn't it? Our AI systems are evolving at this incredible pace, but the old ways of thinking about security, they just don't cut it anymore. Your traditional methods have huge blind spots when it comes to the unique vulnerabilities of AI, and that's exactly what we're here to fix.
Here's our game plan. We're going to start with the foundational checklist from OWASP. These are the absolute basics. Then, we'll zoom out with MIT to understand the bigger picture of risk. After that, we'll step into the shoes of an attacker with MITRE's playbook, see how the whole industry is creating a common language for these new flaws with CVE, and finally, we'll tie it all together with 5 powerful frameworks that you can actually use to build your defense.
First up is OWASP, the Open Worldwide Application Security Project. I mean, if you're in security, you know these guys. They provide the guidance the whole world uses, and for AI, they've given us 3 absolutely essential lists. Think of these as the baseline for any threat model you build.
Now here's what's so interesting about this first list. You might look at it and go, wait a minute, none of this is about AI. And you'd be totally right. The classic OWASP Top 10 is all about the non-AI stuff around your AI system, the APIs, the web apps, the cloud infrastructure. Before you can even think about securing the model, you have to secure the house it lives in.
Okay, now we're getting to the good stuff. We've gone from the infrastructure to the AI itself. This second list is laser-focused on the unique vulnerabilities you find in large language models. We're talking about everything from prompt injection, where an attacker basically tricks the model into doing something it shouldn't, all the way to training data poisoning, and even just outright model theft. This is ground zero for the attack surface of any modern generative AI.
And the third list from OWASP? This one covers your traditional machine learning models. So think about the AI that's been running for years, your fraud detection engines, your malware classifiers. This list deals with threats like model evasion, where attackers craft special inputs to fool the model, and membership inference, which is this really clever attack that tries to figure out if your specific data was used to train the model. Creepy, right? So, OWASP gives us this fantastic, granular checklist of vulnerabilities. But what about the risks that aren't direct attacks? You know, the things that can just go wrong. For that, we turn to MIT, which helps us zoom out and see the entire landscape.
The MIT AI Risk Repository is frankly a game changer because it forces us to think beyond hackers. It's this incredible library of real-world AI failures, and it catalogs everything from safety issues and unintended societal impacts to simple reliability problems and, maybe most importantly, the organizational blind spots that can lead to total disaster.
The repository breaks all this down into 4 key categories. You've got your technical risks, like adversarial ML. But then you've got operational risks, like humans developing automation bias and just blindly trusting the AI. Then there are governance risks, like a simple lack of oversight. And of course, the huge ethical and societal risks, like bias and fairness.
So let's make this real. Imagine you're building an AI to help out your security team in a SOC. The MIT repository would force you to ask tough questions, like, what if my analysts start trusting this AI too much? What happens if the network environment changes and the model's performance just silently degrades without anyone noticing? These are the subtle but absolutely critical risks we need to find.
Okay, we've covered vulnerabilities and broad risks. Now it's time to put on our black hats and get inside the mind of the adversary. For that, our go-to tool is MITRE ATLAS.
Look, if you're in cybersecurity, you know the MITRE AT&T framework. It's the encyclopedia of how attackers breach corporate networks. Well, MITRE ATLAS is the exact same idea, but it's built from the ground up specifically for AI systems. It catalogs real-world, in-the-wild adversarial attacks, giving us a detailed playbook of what to expect.
And each entry in Atlas is incredibly detailed. It doesn't just give an attack a name, it breaks it down completely. It tells you the attacker's goal, what they need to have in place first, the step-by-step of how they pull it off, real-world case studies, and most importantly, what you can do to mitigate it. This is where you find the how-to manual for an attack like training data poisoning that we saw on the OWASP list.
So we've got all these new AI-specific flaws from OWASP and MITRE, and this brings up a huge question for the entire industry.
Yeah, how do we talk about them in a standardized way? How does a vendor report a vulnerability in their AI model? And how does a user know how to track the patch?
That's the exact problem the CVE program is now stepping up to solve.
This new CVE AI working group has a mission that is absolutely critical. They are creating a common language for all of us. They're extending the familiar CVE system you already know to cover flaws in LLMs, machine learning models, and even data pipelines. This means AI vulnerabilities can finally get a formal CVE identifier, which is essential for systematic tracking, patching, and security governance. It's a huge deal.
Okay, we've got our checklists from OWASP, our risk repository from MIT, and our attacker's playbook from MITRE. The final section is all about bringing it all together. These threat modeling frameworks are the master blueprints you use to actually build your defense strategy.
So let's put these resources into action. We're going to walk through 5 gold standard frameworks that act as the blueprints for your defense.
First up, we've got an extension of a classic that many of you probably already know, the STRIDE model. STRIDE for AI takes that familiar framework and injects these new AI-specific threats right into the mix. So right alongside thinking about traditional tampering, you're now threat modeling for things like data poisoning and model extraction. It's a perfect way to adapt a security process you might already be comfortable with.
Next up is AI supply chain threat modeling. This one is all about looking at the entire end-to-end life cycle of your AI system. It forces you to hunt for threats at every single stage, from compromised data way back at the sourcing stage to untrusted models during training, all the way through to making sure you retire it securely at the end. It's perfect for today's complex, multi-vendor AI stacks.
The other 3 essential frameworks each have their own specialty. The NIST AI Risk Management Framework is pretty much the US gold standard for enterprise governance. The MITRE ATLAS framework is what you pull out when you want to focus exclusively on adversarial attacks for red teaming. And the OWASP approach uses those top 10 lists we started with as super practical, hands-on checklists for your applications.
So you see what's happening here, right? The crucial point is this: there is no single magic bullet. A complete AI security strategy is all about choosing the right tool for the right job, and then combining them to cover all your bases.
And this table right here pulls the whole toolkit together. This is your cheat sheet. You use OWASP for your hands-on vulnerability checks. You use MITRE ATLAS to simulate how an attacker might actually exploit those flaws. You use the MITRE repository for high-level governance and risk management. You rely on CVE for tracking and patching. And you use one of the threat modeling frameworks to design your architecture securely from the ground up.
So let's end on this thought. With all these powerful new capabilities, the biggest vulnerability your AI has might not be a single line of code. It might actually be a gap in your security plan. But the good news is, now you have the toolkit to go find it and to fix it.